Hello everyone. What we're going to be talking about in this tutorial is dilutions. Here are the topics we're going to touch in this brief lecture. We'll talk first of all about what dilutions are. We'll define what they are and what is the dilution factors. And then we'll focus on the two types of dilutions you can encounter in a lab. What we call simple dilution or one-step dilutions. We talk about what they are. We talk about the dilution factors and how you can do the calculation to calculate the concentration and the volumes needed to prepare them. Then we'll also go through how you prepare them as well. And then we'll talk about serial dilution. A second type, this is a series, so several dilution, more than one after the other. We'll talk about their definitions, their how you calculate the total dilution factor and the final concentration. And we go through some example of calculations as well. So what are dilutions? Well, dilutions are solutions that are prepared with a reduced concentration starting from another solution. The starting solution, as you can see, for example, in this example here, is referred to as the stock solution. This is a concentrated solution. And the way dilutions are prepared is by taking an aliquot, a little volume from a stock solution, and by adding solvent, additional solvent to that volume. Please notice one thing that in this slide, as in other slides later on, I'll use a graduated cylinder to show you how dilutions are prepared, the concept of the dilution factor, and so on. But the most appropriate type of glassware to use to prepare a dilution is a volumetric flask. I use a graduated cylinder just because it's more direct to see the proportion between the stock solution taken and the overall parts of the solution. So there are two types of dilutions. As we mentioned before, there are simple dilution. They're done by a single step. So this will be the stock solution. You take an aliquot here, add additional solvent, your dilution is done. And then there are serial dilutions where you have multiple dilution, each of them starting from the previous one. So this will be the original stock solution. This is the first dilution. And then this first dilution becomes the stock solution of the second one, and so on. Starting from the simple dilution. So simple dilutions, first of all, can be expressed in different ways. In different ways, it's always based on a ratio, such as 1 to 10 or 1 over 10. This means the same thing. No matter what way they are referred to, like, oh yeah, can you prepare a 2 in 10 dilution or 2 to 10 dilution, whatever way you express it, this number always refer to the same thing, which is basically the parts of stock solution that you have over, over the total parts of solution, not the solvent. Okay. In some rare instances, when you find this with the two dots, this might mean 1 parts of stock, 10 parts of solvent. But in general, please remember this definition. In general, the first number here, the numerator refers always to the parts of stock solution you're taking. And the second one, the total parts of solution. So which would include the additional solvent and that part of stock solution that you have added to this. Now, this is referred to also as the dilution factor. A more practical way to define the dilution factor is as the ratio between the volume of stock of solution, so the one that you took from the original concentrated solution, the volume there, over the total volume of the dilution. For example, here, if you had taken 2.5 milliliter of stock solution and you add 7.5 milliliter of distilled water or solvent to them, now the dilution factor will become the ratio between 2.5 over 2.5 plus 7.5, so the total volume of the solution, hence 1 in 4. This will be the dilution factor that you have done. Practically speaking, what a dilution factor means is basically tells you how many milliliters or liters, depending on the unit, as long as you have the same unit on the top or the bottom. But let's say how many milliliters of stock you will need to prepare these milliliters of solution. So if you had to prepare, in this case, 4 milliliter of this dilution, you would take 1 milliliter of stock solution. If you have to prepare 4 liters, you would take 1 liter of stock solution. Now, if this number here increases, let's say it becomes 10 times more, 40, you have to prepare 40 milliliters. Now the numerator as well, so the parts of stock would increase proportionally. So if you have to prepare 40 milliliters of stock solution, now, sorry, of dilution, you would have to take 10 milliliter at this point of stock solution. So the ratio will stay 1 to 4, which is the dilution factor. Now, let's give you some example. Let's get practical. That's what I'm trying to get to here, the more practical aspect of dilution. So if you're asked to prepare 25 milliliters of a 2 in 5 or 2 over 5 dilution, what volume of stock would you take? As we said before, what the dilution factor basically means is that if you had to prepare 5 milliliter of solution, you would have to take 2 milliliter of stock solution. So at this point, you can actually solve how much you need to prepare 25 milliliter by simply writing an equivalency here. So if I need, again, I'm writing reasoning. I'm not writing a formula, I'm writing reasoning in this case. So, and what this reasoning tells me is that if I need 2 milliliters to prepare 5 milliliters, which is the dilution factor, how many milliliters would I need to prepare 25? These should still give me 2 over 5 overall. And so by resolving this, you can figure out you will need 10 milliliters of the stock solution to prepare this dilution. Now, a faster way, once you get more practical, and basically it's just resolving this equation here. All you need to do is to multiply the total volume of the solution by the dilution factor, which indeed is nothing else than resolving this. So X will be equal to 25 milliliters if you move it to this side, so the total volume times the dilution factor. You can go straight to this quick formula here if you want to do it faster. Now, how would you prepare, practically speaking, this dilution? So you have calculated at this point that you need 10 milliliters and you have to prepare a 25 milliliter dilution. So what you would do? Well, you will be starting from your stock solution. Now, when you prepare a dilution, or no matter what you are doing, starting from a precise stock solution, you never take a volume out directly from a stock solution. So you wouldn't take the 10 milliliters that we calculated in the previous slide, you wouldn't take them directly from the stock solution. But first, you would transfer, you would just pour into a tiny beaker a little aliquot of stock solution. This is roughly a little bit more than what you need. So in our case, a little bit more than 10 milliliters. Why do you do that? Is that if you make any mistake and you contaminate the stock solution, now you still have plenty to work with. If you instead you're taking your 10 milliliter directly from the stock solution and you make a mistake, you contaminate it, you got to prepare a new stock solution. It's much more work. So once you have your aliquot there, now you got to take the 10 milliliters. Now, dilutions are solutions and they have to be prepared with the highest accuracy possible. Okay, so what will be the best pipette to use to take the 10 milliliters of stock? You can think about it for a second. It will be, if possible, a 10 milliliter volumetric pipette. So that's what you would aim for. Obviously, if it's not available, you would settle down for a more or serological pipette. But if it's available, this will be the best pipette, 10 milliliter volumetric pipette. And then you would take these 10 milliliters of stock and you would transfer it to what? Yes, a volumetric flask. You will be looking for a 25 milliliter volumetric flask and you would transfer these stock, 10 milliliter of stock to this. And then you would have to bring it. You don't add 15 milliliter of solvent, but this volumetric flask has a marking for 25. So all you have to do is add solvent to 25 milliliters. And the way you do it is exactly as you were suggested to do it with solution. So you will be adding the solvent first in a fairly gross way. You can go straight from the bottle up to 80-90% of the total volume. So 80-90% of 25 milliliters, so below the marking here. And then, as in solution, you will finish it up, adding drop by drop the additional solvent until you reach the 25 milliliters. Once you reach the 25 milliliters, you will mix it and your dilution will be ready. Okay. All these steps, again, step by step, are done trying to ensure the maximum accuracy possible. Now, you figured out how to do the calculation on how much stock you need to prepare a certain dilution based on the dilution factor and the total volume of the dilution. Now, what will be the concentration that you get after you perform the dilution? Well, the concentration of the dilution ultimately goes down proportionally to the dilution factor that you're using. So what it means that if you start from a stock solution, which is zero point 0.2 molar, for example, and you do a dilution 1 in 10, the concentration on the diluted solution will be 1 in 10 of what the original solution was. So it will be 0.02 molar. If you do a dilution 1 in 100, it will be 100 of 0.2 molar, 0.002 molar, right? So basically, all you need to do to figure out the concentration of the dilution is to take the concentration of the stock, so in this case 0.2 molar, and multiply by the dilution factor. In our example before, our dilution factor was 2 in 5, so we'll be multiplying 0.2 molar times the dilution factor 2 over 5, and this will give us the final concentration of the diluted solution, 0.8 molar. Okay. Now let's go through some more example, 2 slides of calculations here. So 3 slides actually. So you have to prepare 200 milliliters of a 3 in 8 dilution of 20 milligrams per milliliter copper sulfate pentahydrate. Okay, this is a way of expressing concentration as mass over volume, so weight over volume. Do you remember when we talk about solution? So you have to prepare 200 milliliter of a 3.8 dilution. So first question is, what volume of stock would you need, right? We have already done this part before, but so what the dilution factor tells you is that if you have to prepare an 8 milliliter dilution, you will need 3 milliliters. So how much would you need for 200? Write down this reasoning. If you need 3 milliliters of stock to prepare 8 milliliter of dilution, how much would you need of stock to prepare 200? These ratios should be the same. So if you resolve this, you will figure out that the volume of stock that you need is 75 milliliter. So you would have to take, practically speaking, 75 milliliters of the stock to prepare the 200 milliliter of this solution. Now, what is the concentration of the diluted solution? Well, we know the starting concentration. We know the dilution factor. Now we can calculate it. We know that this concentration will go down proportionally to the dilution factor. Therefore, if I multiply these by 3 over 8, so stock concentration times dilution factor, I will get that the final dilution will be 7.5 milligrams per milliliters, which is 3/8 of 20 milligrams per 1 milliliter. Okay. In alternative, to figure out the concentration and other values, you can use this terrible formula. I don't like it personally because I find this formula is oftentimes used without really reasoning. So I rather go through the reasoning first and then I'll throw you this formula here. But this formula basically tells you that if you multiply the concentration of the stock solution, C1, times the volume that you take from this of stock solution to make your dilution, this product should be equal to the product between the final concentration of the dilution and the total volume of this dilution. So one always refer to information from the stock solution to information from the final dilution. Okay, so in our case, if you have to prepare 15 milliliters, let's go through an example how we can use it. Of a 1 in 3 dilution of these stock solution, 20 milligrams per milliliter copper sulfate pentahydrate here. What will be the concentration of the diluted solution? Let's find the information to plug into this formula. So C1 is the concentration of the stock. It's 20 milligrams per milliliter. V1, what is that? Well, V1 is not really given to us. We know V2 is 15 milliliters. But now, if we use this information, so we know that you have to make a 1 in 3 dilution with a total volume of 15 milliliters, you can figure out that you will need 5 milliliters of stock solution, right? So V1 will be 5 milliliters at this point. C2, what would that be? Well, that's what the question is asking about. What is the concentration of the diluted solution? So this will be your variable. And V2 will be the total volume of the dilution, which we know is going to be 15 milliliters. So you know this, 20 milligrams per milliliter. The volume that you need is 5 milliliter. We figure it out. The concentration C2 is what we have to figure out. V2 is 50 milliliters. You figure out that this concentration is going down by 1/3 as well. So it will be 1/3 of 20 milligrams per milliliter. Now, one thing I want to tell you is this. If they don't tell you the total volume, let's say they say, oh, you have prepared a 1 in 3 dilution of, so imagine there is no 15 milliliters here. You have prepared a 1 in 3 dilution of 20 milligrams per milliliter copper sulfate. You can still use this formula. And what you use is what the dilution factor means. If you remember, I said before, this means 1 milliliters of stock for 3 milliliter of dilution, right? So you can just plug in 1 milliliter here and 3 milliliter here. And then you can use all the other information. So once you have the dilution factor, the total volume, if you think, of the dilution is basically irrelevant to resolve anything here with this formula. So moving on here, let's go through another example. So this is exactly what I was telling before. Through the animation, you can figure out the concentration of C2. Now, last example here, calculation for simple dilution. You're given a 2 molar stock solution at this point, and you're asked to prepare 100 milliliter of a dilution at 0.05 molar. Sorry, there is a mistake in here, so let me check it. So to prepare 200 milliliter, sorry, you have to prepare 100 milliliters at this concentration. How much stock would you need? Well, first thing is that we know we're not given in this case a dilution factor, but we know that the concentration goes down from the concentration of the stock solution to the one of the final solution proportionally to the dilution factor. So what it means is that if you calculate the ratio between the concentration of the dilution and the one of the stock solution, you can get the dilution factor, which is what this is doing here. It's a ratio between 0.05 molar between 2 molar equals to 1/40. So this is the dilution factor that you are preparing. Okay. So how do you use that to figure out the total volume of the solution? Sorry, these calculations are based on 200. This was correct. The 100 milliliter was incorrect. I will correct it before I post this. So what is then that you need? Well, we know that if the dilution factor is 1/40, means that if you had to prepare 40 milliliters, you will need 1 milliliter. Therefore, how much would you need if you had to prepare 200 milliliters? See, if you resolve that, you would come out with a volume of 5 milliliters, which is what you would need to pick up to prepare this dilution here, based on the concentration of the final solution you were given. Now, you could have used also, as we said before, the C1, V1, C2, V2, but as you can see, I always keep it as a second option in case you're really desperate, where you would have, in this case, that C1 is the concentration of the stock solution, so 2 molar. V1 will be what you have to figure out how much you need to get, so it will be your X in your calculation. C2 is 0.05 molar, the concentration of the dilution, and V2 is the total volume of the dilution, which is 200 milliliters here. So these will give you obviously as well 5 milliliters to calculate what you need. Now, let's move on to the second type of dilution, serial dilutions. So these are dilutions that are prepared, so two or more dilutions that are prepared starting from the previous dilution, one at a time starting from the previous one. So for example, in this case, you have 3 serial dilution. This will be your stock, could look like a bottle, whatever. You perform the first dilution, and then for the second dilution, your first dilution, this one here, becomes your stock. So this gets diluted again, and then the second dilution here becomes the stock for the third dilution, and this will be your final dilution that you have achieved here. Now, why do you want to do sometimes serial dilutions instead of simple dilution? Well, there are different reasons. The main one is that oftentimes they allow you to be more accurate in the final dilution. When it comes particularly to, so if you have a very big dilution factor, 1 in a million, these will force you many times to take a very small volume of stock, which will be very inaccurate to take. So it's better to break it down into multiple dilution. I'll show you in the next slide an example. Other times is that you have to generate, you find yourself, you gotta do quickly, you gotta generate a series of dilution, which then you wanna study something of, like you're preparing an enzymatic reaction with different dilution of the substrate, for example. You might have, it's very easy to prepare them this way. You just start from a stock, first prepare a bunch of tubes with the same amount of solvent, and then you take X milliliter from the stock, put it on the first one, mix it, take same X milliliter from the second one, you prepare a series of a dilution, which are very quickly to test later on. Example here, as I said before, this is often used to decrease the inaccuracy brought by very small volumes. For example, if you have to prepare a 10 milliliters, that's all you need of a 1 in million dilution. If you had to do a simple single step dilution, if you do your calculations, 1 millionth of 10 milliliters is 0.01 microliters. There is nothing commonly available in a lab that would allow you to measure this accurately. Your error will be huge, okay, if you did it in a single step. So what can you do? Well, you can break down this dilution into different steps. So you can break it down, for example, into 3 serial steps, with each one of them being a 1 in 100 dilution. So you prepare in each step 10 milliliters of dilution, and you take 100 microliters, of the previous dilution or the stock solution. So in this case, if you calculate the ratio, each dilution is 1 in 100, okay? And this dilution will build up over time. Second example, as I said before, sometimes you need to prepare multiple dilutions of the same solute. And so because you want to test that, for example, you want to prepare a graph that correlates the concentration of a substance with how much light it absorbs at a certain wavelength. Okay, you do it all the time. This type of standard curve is referred to. So you want to prepare different dilution? Well, you can do it by taking a serial test tube. Let's say you put 1 milliliter of solvent in each one of them, and then you take 1 milliliter from the stock originally, put it to the second one, mix it, you have 2 milliliters now, take 1 milliliter from here, put it to the second one, mix it, you have 2 milliliters now, you do this, you are creating a series of dilutions here, which progressively grow in an exponential way, actually. And then you have your test tube ready, you will bring them all to the same volume, and you can then measure the absorbance of each test tube. It allows you to prepare this much in a faster way than doing a simple dilution for every single dilution factor that is needed in your experiment. Now, this introduces one thing. As you can see here, this dilution factor is growing exponentially here. Why is it growing? It's because the total dilution factors in a serial dilution is the product between all the dilution factor of each step. So for example, here, the dilution factor at this point right here will be the product of the dilution factor of this step and this step. Each one of them is 1.5. 1.5 times 1.5 is 1/4. At this point, this is 1.5 of what was before. So 1.5 times 1.5 times 1.5 is 1/8. So the total dilution factor, if you go from the beginning to the end, will be the product of all the dilution factor of each step. For example, here, you were doing 3 dilutions of 1 in 100, 1 in 100 here, 1 in 100, and 1 in 100. The total dilution factors will be 1 in a million, exactly what you were trying to replace doing this serial dilution, right? And you can plan it. Now, you can plan it even with different dilution factors. They don't need to be the same in every step. For example, you could do like you could have a series of dilution, the first one being 1 in 5, second one 1 in 10, the third one in 20. Again, the total dilution factor will be the product of all the different dilution factors. So it will be 1 in 1,000 here. So like in simple dilution, now also in this case, the final concentration, so the concentration of the final dilution that you get out of a serial dilution will be proportionally to the original stock dilution, the starting solution, proportionate to the overall dilution factor. So, for example, you have performed these 3 serial dilution, a 1 in 5, 1 in 20, and 1 in 40, right? Starting from a stock solution at 250 grams per liter. So now the total dilution factors, as we say before, is the product of these 3 dilution factors. So it's 1 in 5 times 1 in 20 times 1 in 40, which turns out to be 1 in 4,000. Well, now the concentration at the end of these serial dilutions will be proportional to the original concentration by the dilution factors. So if you multiply the starting concentration times the dilution factor, the total dilution factor, exactly like in simple dilution, basically, you will get the final concentration of the solution. Now, when it comes to final concentration and so on, it's always, sorry, there is a mistake here, I just noticed it. It's always good to write it down in more reasonable, the smallest number of digit possible, right? So in this case here, there's already quite a bit of digit. You can actually just multiply by 1,000 and you convert basically the grams into milligrams. So that's why it's important to be able to convert units very quickly. So in this case will be, my apologies here, this will be milligrams and not milliliters. There's a mistake there. So it will be 62.5 milligrams per liter there. Okay, so finishing up here, what did we talk about in this lab tutorial? Well, we first define what dilutions are. These are solutions that are prepared starting from a stock solution with the goal of lowering the concentration of this stock solution. And the way they are prepared is by taking a certain amount of a stock solution and adding additional solvent to it. Now we talk about also the 2 types of dilutions, simple dilutions and serial dilutions. So simple dilutions are done with a single step. You start from the stock, take the aliquot you need, you add some solvent, you are done. We talked about what the dilution factor is that ratio expressed as X in so on, that tells you basically how much you will need, how many times or how many parts of stock solution you need for the total part of solution. So how many milliliters, for example, of stock you will need for a certain number of milliliters of solution. Then we talked about how the dilution factor affect the concentration, how the concentration goes down from the concentration of the stock to the one of the dilution proportionate to the dilution factor. And we introduced the formulas of a C1 and D1. And we went through some calculations. And also we talked about how you prepare a simple dilutions. We then move to serial dilutions. We discuss how serial dilutions are a series of dilution, more than one dilution, so two or more dilutions than one after the other, connected with each other. Each dilution has its own dilution factors, and the total dilution factor that you achieve through serial dilution is the product of all individual dilution factors. We discuss also why you do them. So usually to increase accuracy, or if you need to quickly prepare multiple dilutions of the same solution. Yeah. And then we went through some calculations to calculate the total dilution factor, but also how the final concentration is affected by all these multiple steps of dilution.